Chapter 14, Day 1, Video Part 2. So we just talked about how if it's going to rain in Salt Lake City, and there's a 50% chance of that, and the probability of rain in Provo is 50% chance, what's the probability that it will rain in both places? And I said, I can't tell you that based off of my formulas up here, because they are dependent. If it's raining in Provo, chances are that storm might move and affect Salt Lake. Okay, let's look at the next question. If the probability of rain in New York City is also 50%, what is the probability that it will rain in both Salt Lake and New York City? Well, now they're a continent apart. So raining in New York really isn't going to affect whether or not it's raining in Salt Lake City. So they're independent. So we could say that the probability of raining in New York and Salt Lake is the probability of raining in New York times the probability of raining in Salt Lake, which would be 0.50 times 0.50 for 0.25, 25%. All right, next question. Suppose that 50% of the cars sold in the country are made in the US, 30% in Japan, and 10% in Germany. Is this a valid assignment of probabilities? How do you know? Well, I'm going to say it could be valid, but we need to add one more section. So if you look down here, okay, probability of US is 50, probability of Japan is 30, probability of Germany is 10. If you added those up, you only get 90%. So we must have the probability of some other countries, cars coming from other countries, being 0.1, because they all have to add up to 100%. So it's valid if we add a 10% chunk for other countries. And we know because they didn't add up to 1 or 100%. All right, question 2. Assuming that the remaining 10% of cars are made in other countries, state the probability distribution for make of cars. Note that a probability distribution lists all of the outcomes of a variable and their probabilities. And again, to prove if it's valid, they have to add up to 1. So this would be our probability distribution. Okay, question B. What is the probability that a car selected at random is not made in the USA? So that is the inverse, and we can write it with a little complement sign, right? USA complement. Well, if the probability, let me talk about this. We could write it USA complement with a little c. We could also write it probability of US complement with a little comma, apostrophe thing, probability of US complement with a little tilde. Okay, and you may even see probability of this. All of those mean complement or not US. And then we have a formula that says the complement is 1 minus the probability of it actually happening, which is going to be 1 minus 0.50 or 0.50, 50% chance. All right, C. What is the probability that a car selected at random is made in Germany or Japan? So again, assuming that they're independent, we go back up here. Oh, I can't find my rules. Let me find them. Aha. Assuming that they're independent, here's our rule, and we just add them. I'm not going to flip back up there. If you need to, you flip back up there from now on. So that is the probability of Germany plus the probability of being from Japan, which would give us 0.10 plus 0.3 or 0.4, 40% chance of being made in Germany or Japan. This rule used in C only works for disjoint events. Explain why these events are disjoint. Okay, we're buying a single car. Okay, and if a car is made in Germany, they aren't going to make part of it in Japan. Okay, you're not getting two cars where one could be made in Germany and Japan, and they usually don't share parts where they're making a car in Germany, but they get the parts from Japan. So it's a single car, so there's no way for it to be from both countries. E, what is the probability that two cars selected at random are both from Japan? So this is an and question, or intersection, which would be the probability of Japan times the probability of Japan, which would be 0.3 times 0.3, or 0.09, or 9%. Note, in cases where the population is very large compared to the sample, it is okay to treat trials as independent even when sampling without replacement, since the probabilities will be very small. The change in the probabilities will be very small. We've talked about this before. Okay, F. What is the probability that none of the three cars from Germany come from Germany? So again, this is Germany complement, or Germany complement, or Germany complement. Well, the probability of being from Germany is 0.1, so the complement is 0.9 times 0.9 times 0.9, or 0.729, which is about 72.9%. Again, you can write it as decimal or percent. I would say if it starts out as a decimal, leave it as a decimal. If it starts out as a percent, turn it back into a percent. What is the probability that at least one of the three cars is made in Germany? Well, at least one. That would mean we could have a German car and two others in any order, or two German cars and another one in any order, or three German cars. And so instead of having to figure those out, we actually just use the formula of 1 minus no German cars, because the opposite of having one or two or three German cars is none. Okay? So we want the 1 minus the probability of none or no German cars. Well, German cars complement is 0.9. So the probability of no German cars we found right here. So we're going to do 1 minus 0.729, and we get a probability of 0.271. And if you have questions about this one, ask me in class. It never goes away. Okay, H. What is the probability that the first time you get a Japanese car is on your fourth selection? So you're listing, you have a thing full of cars where 10% of them are German, 10% are from other countries, 30% of those cars in the bag or whatever you're looking at are from Japan, and 50% from the US. What is the probability that the first time you grab a car is on your fourth selection? Grab a Japanese car is on your fourth selection. Well, that means that the first one is not Japanese, the second one is not Japanese, the third one is not Japanese, but the fourth one is. So we're just going to multiply those up. Japanese is 30% chance, so Japanese complement would be 70% chance the first car you pick is not Japanese, 70% chance the second car, 70% chance the third car, while the last car we want it to be Japanese, so times 0.3, and we get 0.1029, or 10.29%. Lastly, what is the probability that two cars selected at random are both from the US or both from Japan? So both would be and, okay, both, or that's the plus, okay, and then using our rules, if we have and, we multiply, and if we have or, and I really should have written or right there, but that's okay, we times, and so now all we have to do is plug those in. So probability of being from the US is 0.5, and 0.5 plus from Japan, that's 0.3 times 0.3. Therefore, the probability of getting two cars from the US or two cars from Japan is 0.34, or 34%. This is the end of the video. Again, we will start homework 2 in class. Thank you. Come prepared with questions.